In this video, I'm going to make some leveling jacks for my lathe. These pads, they don't really offer the greatest stable platform for the machine. They're spongy, and if you see on my machine, my floor is pretty uneven. So at the highest point over here, it's hard to tell from the camera, but it's probably about almost 2.5 inches off the ground, and that becomes very unstable for the machine. So when the machine is running, it starts to shimmy, and it's a problem. It's coming out in the finish and everything. So to fix that, we're going to make ourselves some nice leveling jacks. And I've made 3 of them already before I decided to make this video, and I started to videotape the making of the last one, so it's going to be kind of a hodgepodge of different footage. These leveling jacks are made up of 2 pieces. You have the base here, which is 4 inches wide, and you have the jack plug, which is 2 7/8. Thread pitch is 13 threads per inch. It's bored down about 3/4 of an inch, and these plugs, they're 1.25 inches tall. So when this sits fully down inside, there's 1/4 of an inch exposed. I'm going to be drilling some holes around here to stick a bar in there to act as like a wrench to raise them and lower them. And they're solid, they're really heavy and they're solid, and they're going to hopefully do a good job by keeping the machine stable. I have a 60-degree hole in here. That's going to accept pins that have a 60-degree point on them, so the machine won't slip. So the first step that we have to do is we have to drill a 1/2 inch hole through the entire length of the base. That's going to be to bolt down. This one here that you see in the picture, in the video, is it hasn't been counterbored yet, but there's going to be a counterbore here to fit the head of the nut. So anyway, the first step is to drill a 1/2 inch hole. Then we're going to bore it. Then we're going to groove it, so we have a little place for the threads to dump out into. Then we're going to thread it, and then we're going to cut the plug. I have a length of this already threaded, so I just slice it off as I need it for each one. Alright, so let's start drilling. Got the piece chucked up and we're ready to go. Put some oil. We've exited out the other side, made it through. Alright, the next step is we're going to start boring. Well, as luck would have it, I don't have a boring bar that's small enough to start boring in a 1/2 inch hole, so I have to open it up with a larger drill bit, and here we go. Alright, we got our holes drilled and I started boring. I'll tell you a little bit about the boring setup here. It's a high-speed steel boring bit, just in a regular bar. It's held off at like a 45-degree angle. I got it in the Alloris tool post, and I have it mounted to cut on the other side. So I'm running the machine in reverse. I got the feed going in reverse to feed it forward, if you could follow along with that. So here we go. We're taking like 60 thousandths off each pass. So feed in 20, 40, 60 thousandths. I got my micrometer stop set up, and I'm basically just watching it as it's cutting. It's getting close. Right before the micrometer stop right before it hits the micrometer stop, I take the clutch off and feed it in by hand. Real simple operation. Very nice smooth finish. Try to get in there a little closer for you. Doesn't look smooth, but it sure is. Let's get a measurement and see where we're at. Using the good old Starrett snap gauges, telescoping gauges, whatever you want to call them. I pop that in there, you squeeze them down, you dip it a little bit past horizontal, and then one swift motion, you just pull it right out. I like using a micrometer over calipers because it's really accurate. You get a lot of just nice touch sensitivity here. We got plenty of cutting more to do. What is it? Okay. 20, 40. 60,000. From this angle, I'm actually just watching the shine of the cut meet the shine of the shoulder. And once they come very close, you can just disengage, kiss it off, and we're good. I'll go handheld here for you, let you take a look at. Nice smooth finish. Yeah, the high-speed steel really cuts it nice. Alright, I'm going to take a spring cut now and then get a measurement because I'm getting close. These are the chips that we're getting. They look like fishing lures. Which I will say this, it's beautiful weather here in Pennsylvania, and I should be out fishing right now. Actually, I was this morning. Alright. Let's get a measurement of that. Alright, we're at 711. 2 inches, 711. And I need to be at 2 inches, 800 thousandths. 712. Alright, so I got a little bit more to go. 15. I'll do 20 and take 8 as my final. We're getting a really nice finish here. A high-speed steel cuts so nice, provided you have it ground correctly and sharpened really well. I know a lot of people don't take the extra step, but I grind mine and then I hone mine. I ran into a little bit of a problem here, and I caught it before we had a catastrophic disaster. As I'm feeding in my cross slide that way, the compound is dangerously close to the piece. In fact, if I keep going and let the cut ride out to the end, I'm gonna hit. The front of the compound is gonna hit the piece. So I'm gonna have to readjust this slightly so I could get in there and finish. So bear with me while I do that. The big 1-inch wrench. Now I'm gonna readjust the micrometer stop. Just on the next cone setting, just to get a little bit faster of a cut, and then I'm going to slow the feed way down, just so we get a real pretty finish. We got our tumbler in the D position down here, so D, so we're taking off 3 thousandths per revolution. Alright, now we're going to take our finishing pass. Get a little oil in there. And here we go. Looking like chrome. Alright, I'm going to take the spring cut now. It's going slow. Yeah, it's not taking nothing off. This was a pretty good setup. Yeah, it's just skimming it. Getting really no chips. Then again, I was only taking off 8 thousandths, so I think we're good. What I did was I advanced the micrometer stop about 3-4 thousandths. Actually couldn't tell. A couple of thousandths. I got some chips wedged in there, so it jumped around a little bit. But anyway, I increased the depth by a couple of thousandths, and then what I'm going to do is I'm going to pull the cross slide out. I'm going to set the auto feed so it feeds out and we get a nice cut. What it's really doing is it's just facing off the inside. We took our final pass off. We took our spring cut. It's looking good. I'm going to measure it, make sure we're at the final 2.8, and then I'm going to set up for a chamfer cut. We're about 2/1000 undersized, which that's fine. Three thousandths undersized. I mean, for threading, I think that's going to be fine. That's going to work out just fine. But I'm going to get set up now for the chamfering cut. You know, in case anybody's wondering what this is here, this taper attachment is a magnet and a real pain to clean. It's a magnet for chips and it's incredibly hard to clean. So what I've done is I just draped a t-shirt over it just as a makeshift cover when I got a lot of crap going on here. With the boring makes so many chips and they get everywhere. So I just have it pinned down to the apron with some rare earth magnets, and they hold it real nice. And you know, every now and then I'll just go over to the garbage can and just clean this all off. But it does a good job of keeping the vast majority of the chips out of my taper attachment. They really should make a cover for it. But that's a whole other topic. Alright. I'm going to find a tool holder. Where are you? Where are you? Where are you? Alright, I got this lathe bit here and my carborundum stone. What I like to do before I take a cut is, you know, just give this like a little bit of a quick hone. Just removes any of the burrs or anything that might be accumulated on the tip. This has a very small little radius on it, so I like to hone that too. Yeah, that's pretty sharp. Pretty sharp. Time to get rid of our boring bar out of our tool holder. Alright. We got our tool mounted in place. You might have a question, what is this fan doing on your lathe bed? Well, when I'm boring or cutting and I got a lot of sulfur oil and burning and smoke, this keeps it out of my lungs. Alright. We'll swing our compound over to 45. I gotta say, there's no real easy way to get this camera focused in on there. I'm zooming into the shot. So what I'm gonna do is I'm gonna just go for it by hand here. I like to give my spindle a little twist to make sure nothing's gonna hit. Nice chamfer. Perfectly set up for threading. Alright, what I'm going to do now is I'm going to set up for cutting my groove so I could have a relief for threading. Here's the tool I'm using for cutting my groove. It's a high-speed steel bit. I had to grind this guy by hand. I don't know if the camera's going to pick this up and focus on it. What we're going to do is we're going to load this guy up here. Now I have the depth, or the height, I'm sorry. I have the height set already. Set my micrometer stop. Now for this, I'm going to run it in back gear because I want to go nice and slow. Plenty of oil, as we all know the drill goes. Let me try to get it in for a nicer, closer camera shot. So here we go. We're going to load this sucker up with a lot of oil. A lot of oil. Lock our apron down. There we see the groove is all cut. Next operation is going to be threading, and I guess it's plug time because I want to show you the tool that I use. It's the Arthur R. Warner threading tool. I hope I'm getting the guy's middle initial correctly. I don't know if it's Arthur L. Warner or Arthur R. Warner, but they're out of Latrobe, Pennsylvania, and they make these threading tools, lathe cutting tools and whatnot. It comes in a kit. This is the kit that I got. Again, my white balance is killing me here. Well, I'll read it to you. It's the kit number 18. It's a 1/2 inch threader, and it comes with 2 inserts. So basically, what you have here is you have an outside threader. I'm sorry, an internal threader, and you stand the bit up, the insert up vertically, and then you can cut your outside threads. It's fantastic, it's nice, and it's high-speed steel, which is fantastic because when they dull, you just take them on a stone. You take the tips on the stone. Let me show you. If if you get a burr or anything like that, it's as easy as just taking your stone and just doing that, and you literally just refreshing the tip on it. You do it all three sides. These things come from the factory really sharp, precision ground, and you get a perfect thread every time. You really do, especially at slow speed. You know, you you put your lathe in back gear at the slowest speed, man, you get some really nice threads. So the kit comes with the tool holder. It comes with 2 inserts. It comes with an Allen key or a Torx wrench, whatever it is. I think this is an Allen key. All right, for threading, I'm going to put this into back gear on the slowest setting. Doing the other ones, I found that the slowest setting produces the nicest, cleanest, smoothest thread. So alright, so normal threading applies. We're at 13. We're at an odd thread pitch, 13 threads per inch. So to do that, when you close your half nuts, you have to close them on any of the numbered lines. If you're doing even threads, you could close them on any tick mark or hash mark. But when you're doing odd, you have to close it on any numbered line. So I'm going to set up the gearbox now for 13 threads per inch. We locate 13, which is in the second slot. And it's in position A. Alright, let's just double check. A, 13 threads per inch, slot 2, we're good to go. We got our threading tool all set correctly. We got the threads per inch set correctly on the gearbox. I cleaned the ways down a little bit before our threading operation, so I removed all the chips, any kind of debris, so we have a nice clean path to follow. Dialed in 10 thousandths on the compound, and we're going to take our first pass. I got the machine is set up in the lowest speed possible, and what's going to happen is with these insert tools on this Arthur Warner threading tool, you're going to get a nice little curly piece that just comes right off. It really is a fantastic tool. I can't say enough good about it. So let's do it. Now I can't see in there at this angle, so I just have to use my micrometer thread stop here and use the force. Plenty of cutting oil. I use the Oatly oil, the high sulfur oil. Get it at Lowe's for like $6-7. Now as I'm threading this, as I get closer to the groove, I could actually hear it finish cutting. So I know it's sitting in the groove then, and immediately I disengage the apron. So, cutting oil. Waiting for that number to come around. Get on it. So this is a slow process. I know how many thousandths I got to take off. Somewhere around 80 thousandths on the compound, that is, because I've done 3 of them already. But it's just slow go, no rush. Thousandths. And again, no rush. You want to have nice, clean threads. It's one thing I like to do, is have very high quality threads. One of the things I like to do to clean my threads, toothbrush. Gets in there, gets your threads really nice and clean. Alright, I'm going to shut the camera off and I'm going to finish this up and get it real close, and then I'll be back. Another great tool for cleaning your threads, a nice wire brush. Alright, let's check our piston and see. Beautiful. Nice and snug. You could just hear it. Alright. I'm going to have to drill some holes through here, little spanner wrench holes, set that up in the milling machine, and I'll take care of that, because how else would I be able to adjust it? The next step in here in our project is I'm going to face the remaining plugs that I have cut. So I'm basically just screwing them down into this jack, and the way the chuck spins will keep it tight. And we're just taking a facing cut off of both sides. Arthur R. Warner threading tool. Get yourself one today. They're really good. Alright, getting our high-speed steel tool in place and ready for our facing cut. I think my height might have gone a little by the wayside here, so just throw a dead center into our tailstock. What I like to do is, turn this a little bit, just enough to snug it, to check, because when you tighten this down, it actually affects the height of this a little bit. Got our tool mounted in the tool post holder. We're going to get ready for our facing cut. And let's take this puppy out of back gear. A word of caution, make sure your gearbox is not at a high speed when your machine is on a high speed, because these South Bend gearboxes are not really meant to run at a very high rate of speed. Trust me, I know. Alright, for the facing cut, what I did is I mounted up a carbide bit. I turned the gearbox off because I'm going to feed this thing by hand, and I got it cranked up to the highest speed. And we're doing our facing cut. Just feeding it in manually. Not a real precision surface. I mean, it's going to be sitting under lathe legs, so I'm not really too worried about how the finish is coming out. I'm going to put a chamfer on it now, so it threads into the jack nice. Now the way I'm doing this is I'm just pushing the tool bit in on I have it set at a 45-degree angle, and I'm just pushing it in very slowly. I don't really care for this method. I'd rather go in and use the compound at a 45 and actually take the cut that way, but I'm just breaking the edge really just to help threading. So this will be the end that goes inside, and we just put our chamfer edge on it. So now next step is to face this off and bring it down to final size, final length of this, and then I'm going to drill the 60-degree point in there. The next part of the leveling jacks is going to be to make these 4 little pins. They're going to bolt to each leg, and the 60-degree point is going to go inside the plug and kind of locate itself, and you know, it'll prevent it from sliding off the leveling jacks. It's just a crude drawing hanging up over there, just reminding me of the measurements. So let's go. I'm using some 1117 cold rolled steel for these. Seems to machine nice. It's working out pretty good. So I'm going to start facing this off. That looks good. Now the length of the threads is going to be 2 inches. Plus I need a 1/4 inch for the thickness of the built-in washer, and I need about 1/4 of an inch length for the point. So obviously 2.5 inches. Just want to set the lead angle of my bit a little bit better. $80 thousandths. Seems to like it a little bit better. Taking 100 thousandths depth of cut and 200 thousandths off the diameter. We're taking our last 10 thousandths cut, finished cut right now, to bring it down to the 480 diameter we need to be at. Let's see if we're at our 480 that we need to be at. Yep. Good. The next thing that we need to do is thread this this long part here. So alright, now we need to thread this long section over here, and I'm going to start off by putting a little groove, a little recess groove in here, and I'm squaring up my tool here. I believe this is the Keith Fenner tip right here for squaring your your threading tools and your parting tools. I've seen people parting at higher speeds, and I don't know how they do it. I haven't achieved any success doing it that way. My old shop teacher, old German guy, Mr. Todd. If you're out there and you're watching this, these are the skills you taught me. I got my compound at 29.5 degrees. Zero out my cross slide. Now we set up the gearbox. 13 threads per inch. Alright, I fed in about 15 thousandths on the compound, which really isn't 15 thousandths because of the triangular nature of it. What I like to do is just use this here gauge and check to make sure my threads are right on, and they are. Plenty of oil, slow speed. Not in any rush. And because it's an odd number of threads, I can use any number on the threading dial. If it's an even thread, you can use any line on the thread dial. All that information you could find in your How to Run a Lathe book. So now we're just taking some nice light cuts, not rushing it. Get a really nice clean thread. Nice sharp bit. And you can hear my back gears aren't making all that much racket. These south bends really clang a lot. And it's just really a matter of setting up the back gears the right way, adjusting them so they're not clanging around. And it could be pretty quiet. And I think I've accomplished that pretty well. Oil. What I'm getting in, I don't know if the camera's picking this up, but I'm getting like one nice long curly uniform thread. It goes on beautiful. No slop. Just perfect. Alright, now I'm going to cut this off on the bandsaw, and then I'm going to carve out the point on this, and then we should be done. Well, my video camera, the battery pack died, so I'm going handheld with the iPhone. I've removed most of the material here. I got a finished cut left to go, another 14 thousandths, 15 thousandths. So I'm going to dial that up right now. 5, 10, 14. And here we go. I set the compound for 30 now, 30 degrees. I cranked back the compound, so I have a little bit of travel room here. And bring this in. I'm going to leave a little bit of space. I'm going to lock down my carriage. And using the compound, I'm cutting a 60-degree angle. So now what I'm doing is I'm just going just enough to go under the surface. Gives it a tiny little bit of a relief. Well, there you have it, folks. A completed pin. So again, what this is going to do is it's going to rest right in here and allow the machine to not slide off these levelers. And it'll go in there. It will screw right up in there and bolt on, and that's that.